Hello students, today we are discuss about oxidation state or oxidation numbers. Now, first we will discuss what's the meaning of oxidation state or oxidation number. Oxidation number, its shortcut is OS, or it is also called oxidation number. Now, oxidation number or oxidation state, basically it's a real or imaginary charge which is present on the different species. For example, if you are taking the example of ionic compound like NaCl, then NaCl is ionic compound, so it is having Na plus and Cl negative. That Na plus and Cl negative, it's a real charge, and these real charge are also called OS of the sodium, it means plus 1, and OS of Cl is minus 1. But if we are taking the example of covalent compound like HCl, in this example there is not any real charges, but as we all know that En of the Cl is higher than H. Therefore, these two bonded electrons more shifted towards Cl. So in that case, Cl having partially negative charge and hydrogen having partially negative, partially positive charge. So basically, these charges will be imaginary. Now in that case, we are saying that OS of the Cl is minus 1 and hydrogen is plus 1. So I think it will be clear that what's the meaning of real or imaginary charges. And basically, these charges are also called oxidation state or oxidation number. Now, we are using some rules. By the help of these rules, we can find the oxidation number for any unknown elements. So, first we are discuss what's the rule for finding the OS of any element. Now, rules. The first rule becomes first group element like lithium, sodium, potassium, rubidium, cesium all are having OSH plus 1. Now, the second group element like beryllium, magnesium, calcium, strontium, barium all are having OS plus 2 in their compounds. Now, third one is hydrogen having plus 1 OS, but in case of hydride means when hydrogen bonded with the metals, its OS becomes minus 1. For example, we are taking the example of H2O. Then this H2O, OS of this hydrogen becomes plus 1. But when we are taking the example of lithium aluminum hydride LiAlH4, in that compound the OS of these 4 hydrogen becomes minus 1. Now the fourth rule is OS of the hydrogen, its general oxide is minus 2. But in case of peroxide means, for example, H2O2 or compound in which there is the direct bonding between O and O. These types of compound is called peroxide, and in these peroxides, OS of the oxygen becomes minus 1. And next, we are taking the example of superoxide. Superoxide, the OS of the oxygen like minus 1 by 2. For example, if we are taking the example of KO2, now here is the potassium is plus 1. So both oxygen having minus 1. Now each having oxygen having charge is minus 1 by 2. So in that case, the OS of each oxygen is minus 1 by 2. This is the example of superoxide. Now the next rule is OS of the halogen, that is X. There is the value of X is fluorine, chlorine, bromine, iodine, that become minus. Now by the using of these simple rules, we are finding the some simple examples. For example, we are taking the example of H2SO4. Now in the H2SO4, finding the OS of sulfur. Now first, except sulfur, written all OS of all the elements according to rule. Now, in that example, there are two atoms of hydrogen. As we know that OS of the hydrogen is plus 1. Now, here is the 2 hydrogen. So, the OS of these 2 hydrogen is 2 into plus 1. Now, our aim is finding the OS of sulfur. So, that will be X. Now, plus. OS of the oxygen is minus 2. Here is the 4 oxygen. So, 4 into minus 2. That total becomes 0 since total molecule having 0 charge. Now solving of this equation, 2 plus x minus 8 equals to 0. Here is the x equals to plus 6. So in that example, the OS of the sulfur becomes plus 6. Now in the second example, we are taking the example of HNO3, finding the OS of this nitrogen. Now this hydrogen taking plus 1 plus x plus each oxygen having minus 2. Here are the 3 oxygens, so 3 into minus 2, and this total becomes 0. So 1 plus x minus 6 equals to 0. Here is the x equals to plus 5. So in that case, or in HNO3, the OS of nitrogen becomes plus 5. Now the next example is, we are taking the example of potassium permanganate KMnO4, which having purple color crystals or deep volume crystals. Now finding the OS of manganese Mn. Now here is the potassium is plus 1, manganese is x, and oxygen is minus 2. So 4 into minus 2, 0, plus 1 plus x minus 8 equals to 0. Now x equals to plus 7. So in that case, OS of manganese becomes plus 7. Now if we are taking the example of potassium dichromate, that is K2Cr2O7. It's an orange colored K2Cr2O7. Now finding the OS of this chromium. So here is the 2 potassium, that will be 2 into plus 1 plus, we are written here 2x, since in this example there are 2 chromium. So 2x plus oxygen, each oxygen minus 2, 7h, 7 into minus 2, and total charge becomes 0. So 2 plus 2x minus 14 equals to 0. Here is 2x equals to 12 and x equals to plus 6. So in this example, OS of the chromium will be plus 6. Now in the next examples, for example, if we are taking the example of SO4 2 minus. Now the finding of OS is sulfur. X plus 4 into minus 2 equals to minus 2, since total species having minus 2 charge. Now x minus 8 equals to minus 2. Now x equals to minus 2 plus 8. That is the x becomes plus 6. So in this example, OS of the sulfur becomes plus 6. Now we are taking another example like H2SO5. It's also called persulfuric acid. Now in this, the structure becomes SOH, OH. Now O, basically this becomes H2SO3 5. Now we are having H2SO5. So first we are drawing the structure of H2SO4. If you draw the structure of H2SO4, that will be SOH, since its basicity becomes 2, so that will be the structure of H2SO4. But in that case of H2SO5, the one oxygen is extra, so structure becomes this type. This is the structure of this H2SO5. Now, according to this structure, these 2 oxygen atom, about these 2 oxygen atom. Now, if we are finding the OS directly by the help of this structure. Now, in that case, this sulfur, if oxygen is double bonded, it's having minus 2 charge and sulfur is plus 2. Now, here is the minus 2, sulfur again plus 2. Here is the single bond, sulfur is plus 1, oxygen is minus 1. That is due to the single bond, sulfur is minus 1, this is the plus 1. So total charge on the sulfur becomes again plus 6. And but this oxygen in that side, O bond O, since En is same, so there is no charge due to these 2 oxygens. But in that case, this oxygen more electronegative than hydrogen, that is the minus 1 and that is the plus 1. So these 2 oxygen acting as a peroxide. Now we are calculate by the using of formula. Then in that case 2 hydrogen H2SO5, 2 into plus 1 plus X plus, out of 5 oxygen, the 3 oxygen becomes a normal oxygen. So 3 into minus 2, but 2 oxygen forming a peroxide bond. So for the and as we know that for the peroxide, the OS becomes minus 1. So 2 into minus 1, it becomes 0. Now 2 plus x minus 6 and minus 2, it becomes 0. Now 2 plus x minus 8 equals to 0 and x equals to 8 minus 2, that becomes plus 6. So If we are using the peroxide, then carefully use the OS of the oxidation -1. Now, in case of peroxide or any other example, we are finding the OS directly by the using of rules and by the following of this types of algebraic equation. Or we can find out the OS also by the using of these types of structural formulas.